So, who here wants a colonoscopy? No one, right? For those of you lucky enough to be unfamiliar, it's a fairly invasive medical procedure. So wouldn't it be better if we could just eat a computer, have it perform its tests in our stomach, and then pass on a sample to our doctor later? Well, we can't quite do that yet, but what we have been eating for quite a while are probiotic bacteria. So these bacteria are found in things such as yogurt, kimchi, or more importantly as tiny pills sold in your local drugstore. So my research aims to turn these bacteria into tiny computers using genetic circuits, so that we can just take a pill, have it perform its tests, and pass on a sample. So a computer will take an electrical signal, or an input, run that through its circuits, and decide whether to turn on or off an output. I want my bacteria to sense a chemical input in your stomach, such as a disease marker, run that through a genetic circuit that we're going to be putting into the bacteria, and then turn on or off an output such as a drug or a colored compound that we can analyze later. But before we can construct the big circuits, we first have to start on the top left, seeing how the smaller parts work and interact. So some of my work has been examining these smaller parts and seeing which ones we could mix or match into a larger construct or circuit. Once I have my circuit, I put it into my bacteria cell, and it's going to tell us how the cell will react in certain environments. So to test these circuits, I actually expose my cells to different chemical inputs in lab, and I measure the output to see, is this how my circuit was supposed to behave, and does it fit my prediction? So we can imagine later on in the medical field, we can expose it to different disease markers, and if all of them are there at the same time, maybe we can make a diagnosis, and the circuit will tell the cell to turn on the output, which could be a drug or a colored compound, to analyze later. If all of our inputs aren't present, then maybe we don't have enough information to really diagnose anything, and the circuit will tell the cell to not produce an output, and we'll have no reaction. So in this way, I'd like to start making larger and more complex circuits to turn these bacteria into really robust and non-invasive diagnostic and therapeutic tools. Tools that we can use cheaply and easily to diagnose a range of conditions that can be found in your intestine, such as cancer or Crohn's disease. So thank you very much.